So here is problem 3 in homework 18. And we have this toggle clamp thing that's used to hold down legwork. So like when you actually press past this little spot, and it'll actually like snap into place, and like it won't. It's called a toggle because it actually will do that. It'll toggle and clamp the thing and hold it down in place. It's kind of cool. So here the dimensions are 1 inch right here, 1.5 inches, or 4.5 inches right this distance. C is this distance, that's 1.5 inches. D, this is 4 inches. E, this is 3 inches, and this is like 36.87. So this would be like, there'd be like a 3, 4, 5 triangle kind of thing in there somewhere. So anyway, we want to figure out what the force is right here if we put 15 pounds right there. So let's go to work on this. And as with many of these things, I don't know the answer. I don't know the answer yet. But I think one of the strategies is this being a 2-force member right here. We can figure out what the force at B is going to be, I think, because of that. Yes. No. Well, first off, I think, okay, we can get this 2-force member. Let's figure out the 2-force member. Let's figure out what's going to be at B, and then we could take this thing and take the sum of the moments about A and have B creating and figure out what this load is. So that's our strategy right here. Did you pick up on that? And that was just me thinking through the thing. I mean, I didn't know how to solve this right up until this moment. I picked out the problem, but I didn't like look at the solution or anything. So I'm going to start off with this member right here. And so let's draw them. Okay. And I think, yeah, something like that. I don't quite know what some of this hidden stuff is going to look like, but I do know that let's make this is going to be B. B is higher than D by about A, by A right there, right? Right. So this has a distance right there. Here you go. Here's our 15 pounds. And I used 15 pounds in all 3 of these problems just to, we could have like a little bit of a comparison thing going on here. Okay, so our distance to this point, this is D right here. That's going to be B. That's our 4.5 inches. All right, and this guy is going to be FCD. And we note that right there is that angle beta. Try to put him in there. And I'm going to guess these as positive. Okay. And so that's going to be FBX, FBY. So if we take the sum of the moments about B, that's going to let me find FCD. And noteworthy that this isn't just one force. There's going to be a moment going this direction and a moment going this direction. right in there. So let's start off though first. Let's see. Oh, I need these dimensions right here. So this distance between C and between here and here is C. And now this distance right here, though, A is 1 inch. Even though it doesn't look drawn to that scale, huh? So let me take 15, going counterclockwise about B, and 4.5 and 1.5 should be 6. Yes. Okay, and now part of this is going clockwise, and part of it's going counterclockwise. That's interesting. Let's go the counterclockwise. FCD, and that's going to be the cosine of 36.87, and that's going to be times the 1 inch. And then the other one, though, so that's going counterclockwise. The other one's going clockwise, and so that's going to be minus FCD times the sine of 36.87 and times 1.5. All right, so I hope I did that right. So I'm going to find out what my FCD is going to be equal to. So it's 15 times 6, boom. And I hope this one's going to be bigger than that one. That's an important thing. 36.87 sine times 1.5, boom. And that's disconcerting. That's 0.9. 0.9. And 36.87. It's going to be cosine. Is that 0.8? Ooh, yeah. But this one subtracts from there, so it's boom. And so we end up with 0.1 here. And so we divide our, this was 90. We divide that 90 by that, and we get 899.97. Let's say it's 900, okay? You can see how many, yeah. At 4 sig figs, it's 900 pounds. That's impressive. 900 pounds out of 15. You put 15 here and you get 900 pounds right there. That's impressive. Okay. And then from that, we're going to be able to get what FBX is going to be in FBY. So some of the forces in the X direction, we're going to get 900 times cosine of 36.87 and nothing else. So that means this guy is going to be in the opposite direction. So FBX is equal to negative 900 times 36.87 cosine, boom, 720, negative 720 pounds. So going that way. And then some of the forces in the y direction equal 0. And we have 15 coming down. And then we have a positive 900 going sine 36.87. And then FBX is what FBY, excuse me. I shot that up, but that too is probably going to be in the negative direction. Yeah. So we take 900 and 36.87 and take the sine of it and multiply. I get 500. We have to subtract out 15 too, though, and you get negative 525 pounds. All right. So now what we do is we take this piece, take the FBD of it, and here's the load FE that's going to be placed on here, and here is a load here, and here's a load right there, and we'll just draw these in place because we're not going to care about this pin right here, but he is FAY and FAX. But here, okay, so I want to draw these in here correctly. All right, so this one, now, this is a little bit of a lot because it's always better if I were to redraw this with the correct directions, right? So, excuse me. In the X direction, this thing is actually pointing on here onto this, which means it's actually pointing up to here. So this is the correct direction right there of my 720. Right, and so in a similar way, this one is supposed to be up, but we found out it's actually down. So it's actually pushing down on here, so it's pushing up on here. So this is the correct direction right here of my 525 pounds. And you know, I think I probably want to label that with the symbols onto the thing, and then I could just go ahead and put the values back in there. So this is my FBX, and here is my FBY, and the sum of the moments about A, you can see that we have, I'll take FBX first, negative 720. Oh, I should have got the dimensions. This is E right here is 3 inches, and in between these two is D, which is 4 inches. Right, so this times the 3 inches, this X. This is also clockwise, so it's a 525. But that one's going to be times the 4 inches, right? And then FE, which is the thing that's we're working against right there, is going to be times our 4 inches. So we had FE equal to get an amazing 1,065 pounds. Holy cow. That's pretty impressive. Let me do that again. 723 times 525, 4 times, add them together, divide by 4. Yep. So that is an amazing amount of output. And so the mechanical advantage is going to be 1,065 divided by 15, or 71. That's pretty impressive. But I didn't ask for a mechanical advantage, so no big deal. Maybe I should have, but I did. So there you go. These are 3 pretty easy questions, I think, overall. So fair game on an exam, just, you know.